Good morning, everybody. Welcome to Wednesday morning of Chem 1211 with your host, me, Dr. White. Hi. All right. Dr. White's been a busy person the last day or two. And part of that busy is does everybody see Chem 1211 Quiz 3 important information on your screen? Thank you. All right, let's go through this. I posted this morning, and I will be giving quiz number 3 next Wednesday at 11 a.m. At that time, I will be emailing you the password for quiz 3 PDF file. You'll have until the next day, Thursday morning, 11 a.m. That gives you 24 hours to take quiz number 3 and upload your answers to quiz number 3. And this is important as a single PDF file. And just like you've done the labs, I'll have instructions how to do that. Now, as I did for the first 2 quizzes, I reserve the right to subtract up to 25 points from your quiz number 3 total points for anybody who doesn't follow instructions. In other words, a single PDF file, or anyone who does not upload your quiz 3 answers on time. Now, quiz 3 has 4 pages, 8 problems, it's 50 points. It covers only chapter 11, gases. And I would recommend that you download the PDF file the day before, and I'll have a periodic table that you can download the day before, which would be next Tuesday, sometime in the afternoon. I will post the quiz 3 scores by the following Monday, 1 p.m. or earlier on Blackboard. At that time, I will post an announcement and send you an email with your announcement and your let me send you an email that your quiz scores are in Blackboard. Oh, I tied myself up in knots on that. All right, I'll also email you each individual student, the points you receive for each problem of each part of a problem for quiz number 3. On Monday, following the quiz, I will go over quiz number 3 in our Zoom meeting, but I'll delete that from the video. I like my special effects. I'll cut it out. And if you can't make the Monday Zoom meeting, when I go over the answers, then you can come to my office hours, or if you can't come to my office hours, contact me by email, and I'll set up a private Zoom meeting so you can go through those answers. Was that good? Blueberry tea from the Republic of Tea. All right, some more information about quiz 3. Next Monday, I will go through and do a review for quiz number 3. And on Blackboard, if you go to course information, lecture folder, like I said, I've been a busy boy lately. You'll see all the way near the bottom, quiz 3, important information, both as a Word doc and a PDF file, and quiz number 3 review as a Word doc and a PDF file. And I'll go through this review on Monday. Now, For those of you who did not do good on test 1, which a majority had problems with converting from grams to moles, moles to grams, watch yesterday's, I like special effects, yesterday's video. I did at the very end. I went through a problem. And if we have time today, I'll do another one at the end of today's lecture. We finish up a little early. We might. If not, I'll do it again next week during the lab. So don't forget, do the practice problems. Don't just watch the video and say, oh, I know how to do that. You don't. Do the practice problems, then look at the answers. If you're having problems, come to lecture or come to my office hour or email me and say you need help. Also, as I mentioned yesterday, COD has, I believe, online peer tutoring. I'll have to look that up tomorrow, Monday, or send out an email. And that's that. Any questions? I'm looking down at the chat. All right, let's get back to chapter 12. This will not be on quiz 3, but it will be on quiz 4. Everybody see molarity on your screen? Thank you, Giannis. Oh, in plural. All right, we're talking about concentration and concentration of a solution, which I'll never ask you for this definition, but you should be familiar with it, tells you the amount of solute present in a specific amount of solution. So I talked about, but click, this won't be on a test, percent by mass and percent by volume. But if I could turn, the dial only goes to 10, I've just turned it to 25 because that's molarity. Molarity, which is designated by a capital M, I'll show you how that works, of a solution is a ratio giving the number of moles of solute per liter of solution. I don't even have to write it. It says it. Very important. No. Now, because 1 liter equals 1,000 milliliters, molarity, which is moles per liter, is also moles per 1,000 milliliters. So what does this mean? Good question. Thank you. In fact, it's such a good question. I'll write it on and the question is, what does this mean? And whenever you see a capital M means molarity, which is equal to moles of solute per 1,000 milliliters of solution. ml means milliliters. So what does this mean? As soon as you see the capital M, that means molarity. And what it really means is 7.23 moles of HBr, which is hydrobromic acid, or hydrogen bromide if it's a gas, but in this case, it's in a solution, per 1,000 milliliters. Oh, that was fun. Let's do another one. And what does this mean? As soon as you see the capital M, that means molarity. And molarity is moles of solute. In this case, that's 3.12 times 10 to the third moles of lithium chloride. That's LiCl per 1,000 milliliters. Oh, I better share the fun. What does this mean? Your turn. Have some fun. And when you're done, what does that mean? Give me a thumbs up. I see one thumb, and it isn't Tom's. Tom Thumb, boo. It's totally miserable humor Wednesday. Sorry about that. I'm done too. And I see another thumb. And everybody's done, so it's my turn to have some fun. What does this mean? As soon as you see a capital M, that means molarity. And molarity is moles of solute per 1,000 milliliters. So what does this mean? 3.856 moles of sodium chloride, table salt, per 1,000 milliliters. Oh, let's do one more. I'm having a good time. Hopefully you are. And why don't you do this one? What does that mean? And when you're done, give me a thumbs up. Oh, I see one thumb. Oh, two. But we'll wait for everybody to finish. And we did wait. What does this mean? As soon as you see a capital M after a number and a chemical structure, that means molarity. Molarity, moles of solute per 1,000 milliliters. What is the solute? Whatever after the capital M. So what does this mean? 4.111 times 10 to the minus 2 moles of hydrochloric acid or hydrogen chloride per 1,000 milliliters. Now, quick reminder, yesterday in our lab, one of the solutions that you will use is this. And what does that mean? that solution is 1 mole of HCl per 1,000 milliliters of solution. Now, let's look at another problem. All right, everybody see 4 points each on your screen? Thank you. All right, question. What does this mean and what is the solvent of this solution? And I'll do this one, and you know I'm going to share the fun, and I do. All right, what does this mean? Well, capital M means molarity. And that's equal to moles solute per 1,000 milliliters of solution. But something else, bracket AQ close bracket means solvent. Isn't it amazing when I say it, it writes it on the board? Not yet. Solvent is water. So what does this mean? First of all, capital M molarity. So 2.65 moles of KCl, potassium chloride, per 1,000 milliliters, and solvent is water, or you could write it out. And that's what this means. AQ, as I mentioned earlier in this chapter, is for aqueous. And that tells you in aqueous solution, the solvent is water. And I guess I could say my tea is aqueous because the solvent in my tea is water. Boy, I never thought tea was chemistry. Well, it is. All right. Same question, your turn. Again, the question is for B, what does this mean? What is the solvent of this solution? And for B, you see 3.33 capital M H2SO4 bracket AQ close bracket. Your turn. Again, what does that mean and what is the solvent? When we're done, give me a thumbs up. I see one thumb. I've got two thumbs. And I see the rest. Everybody's done. So it's my turn. As soon as you see capital M between a number and a formula, that's molarity. And molarity is moles of solute per 1,000 milliliters of solution. And therefore, what does this mean? 3.33 moles of sulfuric acid, H2SO4, per 1,000 milliliters of solution. And what is the solvent? Bracket AQ bracket tells you the solvent is water. Oh, let's do one more. And why don't you try C? What does 25.67 capital M CaCl2 bracket AQ close bracket mean? And what is the solvent? Your turn. Hint, hint, big hint. And when you're done, give me a thumbs up. I'm done. Actually, I haven't started yet. I see one thumb. Oh, excuse me. I got up too early this morning. Way too early. Well, normal almost for me. And I'll wait for everybody to finish. All right, let's do this. What does 25.67 capital M CaCl2 bracket AQ close bracket mean, and what is the solvent? As soon as you see capital M between a number and a formula, that means molarity. And molarity is moles of solute per 1,000 milliliters. And therefore, what does this mean? 25.67 moles of calcium chloride, that's what CaCl2 is, per 1,000 milliliters of solution. And hold on. It's hard not to. I'm used to writing milliliters like this, but this is cursive. In case I do and you forget, 3 lines means identical to that. And what is the solvent bracket, AQ close bracket for aqua or aqueous? And that means solvent is water. Now, why is Dr. White and me getting all excited about molarity? Well, it turns out the concept and use of molarity is very useful in a lab and even in a chemical plant or anywhere they use chemicals. Why? Because that allows you to measure out a certain amount of moles by volume. What does that mean? Well, if you were to go into your lab kit, or if you go into the stock room, chemical stock room at COD, you'll see bottles or bigger bottles with labels on them that are molar solutions, just like I showed you. And by having that, I can measure out easily. Measuring volume out is very easy. How many moles I have and to use. So let's take a look at this. All right, everybody see the problem? 6 points on your screen right now. Thank you. All right, you know the drill. The first thing I'm going to do is ask and answer, what am I being asked to find? And the answer is, how many moles sulfuric acid, H2SO4? And what am I given? Ooh, 2 things. First of all, there's 581 milliliters of solution. And second of all, this number, 3.45 capital M H2SO4, sulfuric acid. And once I have this, I do not have to look above anymore, and I won't. So the first thing I'm going to do is says, what does this mean? I see the capital M between numbers and a formula. I know capital M is molarity. That means 3.45 moles of sulfuric acid per 1,000 milliliters. And because this is a definition, the 1,000 is an exact number. Because it's defined moles per 1,000 milliliters, the 1,000 is the exact number, but the 3.45 is 3 significant figures. So how do I proceed? Good question. Thank you. Well, the only thing I really have up front is this number. If there was a ratio or conversion ratio I could use, convert milliliters, what units do I want? My answer. Moles of sulfuric acid. And how do I proceed? Are you ready? It's time to use your good buddy, your good friend. Oh, that was a good one. Unit analysis. And how do you use your good buddy, your good friend, unit analysis? Whatever you're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. I'll write those units in. Give myself a little more room here. And where do I get these numbers? From the molarity, which is 3.45 moles of sulfuric acid per 1,000 milliliters. Now, before I pick up my calculator, I'm going to check my units. Notice up here in this equation, and I haven't done this detail like this in the past enough. I'm going to do it now, and this is why maybe some people had difficulty on test one. I have milliliters times moles of H2SO4 divided by milliliters. And notice milliliters divided by milliliters, anything divided by itself equals the number 1, meaning it's gone. And I'm left with moles of H2SO4. So these cancel out by this reason, and I'm left with what I want. So now I can joyfully, I've never used that word before, may not ever again. Happily, I like that better. Turn on my calculator, clear it, put in 581 times 3.45, divide by 1,000. And my calculator gives me this number. And it says 10 to the 0, 10 to the 0 is 1. Remember, this is quiz 4 material. And on quiz 4, like it will say on quiz 3, please use proper significant figures for all calculated answers. And if we look at this problem, 1, 2, 3, 3 significant figures. 1, 2, 3, 3 significant figures. 1,000 is an exact number, which doesn't play a role in determining significant figures. When you're multiplying, dividing, which this is, you get the same number of significant figures in the number you're multiplying, dividing, that has the lowest significant figures. This one, they're both 3. So I'm going to give you 10 seconds to round this off to 3 significant figures. Then I'll do it. Go. I like that. Go. Bonus time. 5, 4, 3, 2, 1. Time's up. How do you round this off to 3 significant figures? keep the 2, that is a 2, keep the 0, keep the 0. That's my 3 significant figures. Remember, 0 after a decimal point are always significant. Use the 4 to round off. Is that 4 or less? And the answer is it's 4. So it's 4 or less. I drop that, and the correct answer is this. So what this really means and why it's nice, if I need 2.00 moles of sulfuric acid, H2SO4, for a reaction, well, I just measure out 581 milliliters of that solution, of this molar solution. And that's what makes molarity a very, very useful concept that's used in everyday life in a laboratory or in a chemical plant. Now, in a chemical plant, you make much larger solutions. Let's see if I can pull one up real quick or even real slow. All right, does everybody see? Let me get images pulled up. See where it says, see the guy standing next to the yellow stand, and there's something on top of that? All right, thank you, Gianna. What he's looking at and what's right here are totes. And totes are standardized, usually a couple 100 gallons. And if you notice right here at the bottom, there's a valve. That yellow handle opens it. I actually, in my collection, in my family room, have 2 of these valves from problems I solved dealing with totes that I took them from totes that we couldn't use anymore as memorabilia. Now you know I'm a chemist. And chemical plants I've worked at, they'll have totes stored of different molar solutions, like sulfuric acid or salts or other chemicals. And if you need a certain amount of moles for a reaction, you measure out by volume. Now, you don't use a graduated cylinder. If it's large enough, you'll have an electronic meter that will measure out gallons that measure in tenths of a gallon. And these, I don't know how they got the name tote, reminds me of the umbrella, but these have been called totes. I don't know how many decades I've been in the chemical industry, too many. And they've been called totes. That you never thought you'd be learning all the secrets of the chemical industry from someone who's lived and worked in it. All right, let's continue and do another one of these. Oops, forgot something. Forgot a lot of something. All right. Question, 6 points. How many moles HBr are in 465.6 milliliters of a 1.356 times 10 to the third capital m HBr solution. Let's do this stepwise. I'll do it and then you'll do it. Let's do it like Winky Dink. After the break, I'll talk about Winky Dink. If you don't know who Winky Dink is, which I'm going to assume each and every one of you don't. All right, first step. What are we being asked to find? What are we given? Your turn. That's all I'm asking you to do. When you're done that, what are we being asked to find? What are we given? Give me a thumbs up. I guess you could also do thumbs down. I don't know, they have a thumbs up like this. Can you do, or the horn emoji? Did I tell you, I'm going to try and get the word emoji replaced with symboli. It makes more sense. Ooh, this is a symbol, a symboli. I guess that's Italian. Oh, it's evolving into really bad humor Wednesday. Just think, you had to pay to hear this. Unless you're watching on YouTube and you're not part of my class, and you still have to suffer through it. Again, all I'm asking you to find is what are we being asked to find unit-wise and what are we given? And when you've done that, give me a thumbs up. Thank you, Gianna. W. There are two Giannas. And over the years, numerous times, especially face-to-face, I've taught a lab or a class where I've had one or more students with the first name. The only time I had difficulty was one time when they were same height, same hair color, similar build. So how did I figure out who's who? Well, I've managed, I found some slight difference. All right, how many people need more time? Wave to me. Oh, you don't have your webcams on. All right, think everybody is almost done. Let's do it. What are we being asked to find? How many moles of HBr? What are we given? There's 465.6 milliliters of solution. Did it again. When you grow up doing cursive, it's hard to stop doing it, going back to printing. We're given these many milliliters, and we're also given this number, 1.356 times 10 to the third capital M HBr. And as soon as I see the capital M, I remember that's molarity, moles of solute per 1,000 milliliters. So at this point, I'm going to kick in and say, what does that mean? And I know that means this. That's 1.356 times 10 to the third moles of HBr per 1,000 milliliters. Now, the only real number we have to start with is this. Print it. I did. Now, what units do we want our answer to be? This. And I'm going to let you, what units go on top and bottom of that ratio. Use your good buddy, your good friend. And when you've done that, give me a thumbs up. Again, what units go on top and bottom, not numbers, just units. Thank you, Gianna J. And it's a Gianna W. And there's a Dr. KW, me. Us W's got to stick together. All right, my turn. It's time to use your good buddy, your good friend, unit analysis. Whatever you're trying to go to goes on top of that ratio. Whatever we're trying to get rid of goes underneath. Did it again. All right. Henceforth, your first cursive lesson. This means ML. And if I write this ML like this in cursive, you should know it. All right, back to our problem. Where do we get these numbers? From the fact that we figured capital M here, molarity, means 1.356 moles times 10 to the third moles of HBr per 1,000 milliliters. Now, you don't have to write this on a paper, but I'm going to show you before I pick up my calculator. I'm going to check, do my units give me the right answer? And notice I have milliliters times moles divided by milliliters. And anything divided by itself equals the number one. 1 times mole would be mole. So this cancels out, and I'm left with the right units. And now I can pick up my calculator, clear it, 465.6 times 1.356, second key double E, 3 divided by 1,000. And my calculator gives me the following number. but I'm going to round it off to the proper significant figures. And when you have a multiplication division, you get the same number of significant figures in your final answer as the number that you're multiplying or dividing that has the fewest significant figures. This has 1, 2, 3, 4. 1,000, and this is an exact number. This has 1, 2, 3, 4. So what's the lowest number? 4. So why don't you round this off to 4 significant figures? Your turn. And when you're done rounding it off, give me a thumbs up. Ooh, this is an interesting one. Thank you, Gianna W. Thank you, Gianna J. All right, my turn. When you're rounding off, keep the 6, keep the 3, keep the 1, keep the 3. Those are my 4 significant figures. The next number we use to round off, 5. Is that 4 or less or 5 or greater? Well, hopefully I'll pick 5 or greater. I'm going to drop all this, increase the number in 1 in front by 1, and the correct answer would be 6.314 times 10 to the 2 moles of HBr. And that's how you do it. That's our answer. So don't forget, the key to all these is, first of all, figure out what you're being asked to find, what are you given, set up a conversion. Remember, capital M, number in front, chemical formula afterward, means molarity. Molarity means moles of solute per 1,000 milliliters. Oh no, I went 5 minutes longer than I normally do. Hopefully you're able to survive that extra time. But anyways, let's take a 5-minute break. Come back at 10 o'clock. I'm going to get up and stretch. See you in 5. I'm back in blue. I was in blue before. Oh, black and blue. All right, let's get back to work. Now, we were talking about molarity, and I'm saying, look how important molarity is by making up stock solutions and using them. Well, how do you do that? Well, let's look at another problem. Remember, what I'm doing now is for quiz 4. Next week, you'll be taking quiz 3, which is on the chapter on 11 on gases. All right, does everybody see on the screen 6 points? How many ml? Thank you, Gianna J. All right, how many milliliters, ml is milliliters, of a 3.62 capital M NaCl sodium chloride solution do you need to obtain 1.25 times 10 to the minus 2 moles of sodium chloride? Now, this type of problem is something chemists do all the time, because by having stock solutions, all you have to do is measure out by volume a certain amount of a molar solution to get how many moles you need. Now, the question is, how do you figure out how many milliliters you need? Well, let's go through this. What are we being asked to find? Milliliters of solution. What are we given? This number, 3.62 capital M NaCl. And as soon as I see capital M with a number in front and a chemical formula afterward, I know that's molarity. That's equal to moles of solute per 1,000 milliliters. But I'm also given this number. I want to get 1.25 times 10 to the minus 2 moles of NaCl. So how do I proceed? Once I have this, I never have to look up there again. So I won't. Well, the only real number I have to start with initially is this, 1.25 times 10 to the minus 2 moles of sodium chloride. If I had a conversion ratio, what units do I want my answer in? Well, we figured that out. Milliliters. That's an ugly looking M. That's better. And now, how do we figure what goes up and down on the top and bottom of that ratio? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top, the units of that ratio. Whatever units we don't want to have in our final answer, we want to get rid of, goes underneath that ratio. And now I'm going to write those in. And now I look around, where do I find a relationship between moles of sodium chloride and milliliters. Oh, wait, right here. What does that mean? The capital M, molarity, that's 3.62 moles of sodium chloride per 1,000 milliliters. And that's where I get that. So on the top, for every 1,000 milliliters, we get that from here. We have 3. Hold on. Getting excited. 3.62 moles of sodium chloride, which we get from the molarity. And now, before I pick up my calculator, I'm going to say, what are my units? You don't have to do this, but I'm doing this because of the mistakes a lot of people made on test 1. I think you could use this sort of help. I have moles of sodium chloride times milliliters divided by moles of sodium chloride. And anything divided by itself is the number 1, which means these cancel out. I'm left with milliliters, which is what I want. So now I can happily, remember I said I wouldn't use the word joyful, not happily, turn on my calculator, clear it, blue double E. Remember on the calculator for minus, use it here, not the minus sign here, but the minus sign on the keypad to get 10 to the minus 2 times 1,000 divided by 3.62. And my calculator gives me this number. Times 10 to the 0. 10 to the 0 is 1, so it's this number, and that would be milliliters. And on quiz 3, like quiz 4, or I should say quiz 4, like quiz 3, it'll say, please use proper significant figures for all calculated answers. All non-zero numbers are significant. So this has 3 significant figures. The 1,000 is part definition, exact number. This would be 1, 2, 3, 3 significant figures. Dr. Whiteson is right of 3 significant figures, and I'll let you round this off to 3 significant figures. Why? Because you have the same number of significant figures in your answer that the number you're trying to or you calculate has in its hand. Well, let me repeat that. You have the same number of significant figures in your answer as the numbers you're multiplying or dividing that has the fewest significant figures. I should make a tape of that and display it. Your turn to round 3.45308 to 3 significant figures. Go. And when I'm looking like this, I'm looking at the video, seeing that handsome chemist in the screen. This turned into a really crazy Wednesday. Remember, your turn. Round it off to 3 significant figures. Let's see one person, Dawn. 2. And it's my turn. All right, how do you round this off to 3 significant figures? Keep the 3, keep the 4, keep the 5. Those are my 3 significant figures. Remember, all non-zero numbers are significant. Use the 3 to round off. That's 4 or less. Drop that. And the correct answer is the proper significant figures. That. So what this really means is if I have a molar stock solution made up that's 3.62 molar sodium chloride, capital M NaCl, and I need for a reaction 1.25 times 10 to the minus 2 moles of sodium chloride, I just measure out 3.45 milliliters and I've got it. And that makes your life really simple. Now, let's do another one of these. Instead of 6 points, this may even be 8 points. All right, let's look at this. How many milliliters of a 7.891 capital M HCl solution are needed? I knew I forgot something here. Are needed to obtain 1.111 moles HCl. All right, what I like you to do first right here is figure out what are we being asked to find and what are we given. That's all I'm asking right now. Your turn. What are we being asked to find? What are we given? And when you're done, give me a thumbs up. Got an itchy nose today, sorry. Thank you, GW. Oh, I'm coming up with new names for everybody. Thank you, GJ. Give everybody time to finish. Finish. All right, my turn. And the question is, how many milliliters of HCl? So we're trying to find milliliters of solution, or HCl, you could have written down, but think of it as solution. What are you given? You're given 7.891 capital M HCl. and you're given, you want to obtain these many moles, 1.111 moles of HCl. So once I have this, I don't have to look up there anymore. Makes your life easier. Now, the only regular number that I know with units initially is this. If I had a ratio to convert this to my answer, what units do I want my answer to be? Oops, I almost did it again. Boy, when you're used to doing cursive all your life, it's hard to stop and turn around to do printing. There. All right, your turn. What units go on top and bottom of that ratio? I'll give you 30 seconds. Go. Remember, all you're trying to do is figure out what units go on top and below bottom of that ratio. And give me a thumbs up when you're done. I see one person done. Thank you. Two people. I'll give you an extra bonus 10 seconds for those who haven't finished. 3, 2, 1. You're done. My turn. All right. How do you determine what goes on top and bottom of that ratio? Use your good friend, your good buddy, your analysis. Whatever I'm trying to get to, milliliters goes on top. Whatever I'm trying to get rid of, moles go, HCl go underneath. Now, I'll draw those in, write those in. And where do I get these numbers? From here. What does that mean? Capital M molarity, 7.891 moles HCl, and I'm running out of room, so I'll do it this way, per 1,000 milliliters. So from this right here, we know for every 1,000 milliliters, there's 7.891 moles of HCl. Now, before I do and pick up my calculator, I'm going to check my units. Now, I don't have to rewrite it. You don't, but because of the problems people had in test number 1, I'm going to take the time to say we have moles of HCl times milliliters divided by moles of HCl. And anything divided by itself equals the number 1, it's gone. So now I'd be left with milliliters, which is what I want. And now I can happily pick up my calculator. Happy because we're on the home stretch to finish this. 1.111 times 1,000 divided by 7.891. And my calculator gives me this long number. And if you write that down, I'm going to take off a point because on quiz 4, like quiz 3, And test number 1 and quiz 1 and 2, it will say, please use proper significant figures for all calculated answers. And how do you do that? You look at how many significant figures in a multiplication division you have, and the number that you're multiplying, dividing with the lowest significant figures is the number that you use to determine the significant figures of the answer. And this one, 2, 3, 4 significant figures. The 1,000 is the part of a definition. Exact number does not play a role. And this number here, 1, 2, 3, 4, 4 significant figures. What's the lowest number? Well, 4 and 4 you have to choose from. Hopefully you pick 4. Your turn to round this off to 4 significant figures. And when you've rounded it off to 4 significant figures, give me a thumbs up. Well, I see 1 thumb. 2. And I think maybe somebody's thumbs emoji is broken. So let's move forward. Keep the 1, keep the 4, keep the 0, keep the 7. Those are my 4 significant figures. Use the next number to round off. So have 4 or less or 5 or higher, and hopefully y'all pick 5 or higher. That means all of this I drop, increase the number in front by 1. And this is your correct answer. So that means if I need 1.11 moles of HCl of this molar solution, I measure out 1.408 times 10 squared milliliters, which another way of saying that is 140.8 milliliters. And that's what makes molarity a very, very, even 3 times, very useful concept in chemistry, both in the laboratories and in chemical plants. Now, molarity is so useful that special glassware long ago was developed to help make stock molar solutions. Does everybody see the pictures of the volumetric flask on your screen? Hold on, let me see. Thank you, Gianna W. All right, these are Van Gianna J. These are flasks that allow you to make stock solutions. Notice the 1,000 on here. This is for 1,000 milliliter solution you're making up. Notice the line right there. It's like a graduated cylinder. You put the solid in, if it's a solid, or if it's a liquid solute, and then you add enough solvent so you come up to the line. And these are very accurate. Usually the accuracy on here are usually plus or minus 0.01%. So everybody see this picture here of the different sizes? Aren't they cute? Oh, that reminds me. All right, I'm going to take a 30-second, maybe a minute, to go get something for show and tell. So I'll be right back. Hang in there, don't leave. It's time for Dr. White's show and tell. I don't know if I told you this when I was in third, fourth, fifth, and sixth, and seventh, eighth grade. We had show and tell. The teachers got real scared. What song? What is Dr. White? I wasn't Dr. White then. But what will I bring in? Why were they scared? Because it was always something chemistry or science related that they had no idea, especially if it was show and tell in English class. What the heck did he bring in? Never anything dangerous or upsetting, but they just said no. But show and tell. Is that cute or is that cute? This is a volumetric class, 25 mils, and they don't have the accuracy. But can you see the line right here? You put in your solid, you fill it up. I have a glass bead in there, ignore it. You fill, say, water or other liquids up there. You have a little stopper. Is that cute? And you take and you mix it like this, and you now have your stock solution that you can put into something else. By the way, I get these on eBay. eBay is a good way. I have in my living room couch table, which I have a lot of chemical equipment on, including my father's balance from his drugstore, which is a very important memento of mine. And I've got an even cuter one. And this is a 10 milliliter. And notice it also has a line up here. You'd put, and this has got a fancy base. Is that cute? Now you know I'm a chemist. And you'd put the solid in there, say sodium chloride or sugar or other chemicals. Then you'd fill up the solvent, say water, up to this line. And then you put the stopper in, mix it, and you have your stock solution. Are they cute? One of these days, I can get my hands on a 5 milliliter. That's going to be really cute. Now, in a lab, besides that size I showed you, they come in all sizes. Now, the largest I've ever used, did I have a picture here? Usually 1,001, which is 1 liter, 1,000 milliliters. And I have actually used a 2,000 milliliter, 2 liter volumetric flask. They get pretty large. Let's do something. And here they have some, you don't see it to scale though, but you can get 2 liter. And I know they have a larger size. I've never used larger than 2 liter. They actually have 5,000 mil or 5 liter volumetric. That's going to be big. That's about 4 liters is a little over a gallon. So this is a gallon and a half in there. And again, you can't see it. There's a line up here, or there should be. Just like here, you see the line right there. So how do you do this? Now, let me get back to our slides. Does everybody see important molarity questions on your screen? All right, number 1 we've done. Let's skip 2 for now. We've done this right here, number 3. Now, since these are so important, the question is, how do you make these stock solutions? Well, one, you can buy them, but now more likely you're going to make them yourself. So how do you make a stock molar solution? I apologize. Today as I want to write in cursive and I shouldn't. And what I'm going to be showing you right now is something chemists do daily. And in a plant, we do it, but just on a larger scale. So notice 10 points. How many grams of sodium chloride are needed to make 451 milliliters of a 2.31 capital M molar NaCl solution? So what are we being asked to find? How many grams sodium chloride? What are we given? We need 451 milliliters of solution, and we're given the molarity of the solution. There's no way I can go directly from milliliters to grams. No way. And there's no way you can either. So what do? You need 2 steps. And what are those 2 steps? I haven't made it up yet. This weekend, I'll put a important information quiz for. Hold on, I have to open something up. All right. Everything I just highlighted will be an important information quiz number 4. And notice right here, molarity 2-step problem. In step 1, we go from milliliters to moles. In step 2, we'll go from moles to grams, which is why I covered it yesterday in lab, after lab yesterday in the video. And go back and watch it. So we need these 2 steps. In the past, you would have to memorize this. This will be given to you. Important information. Quiz number 4. But you're going to have to know how to use this. So let's go and do it. All right, step 1. Milliliters to moles or whatever we're trying to get to, in this case, sodium chloride. Well, there's only one number I have to start with, and I will. Oops, let me write it down correctly. 451 milliliters of solution. By the way, this is cursive for ml. We want to get to moles of whatever answer we're trying to get to, sodium chloride. And now you'll use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of that ratio. Whatever I'm trying to get rid of goes underneath. And I'll write those units in. And where do I get a relationship between moles of a compound and milliliters of a solution? From the molarity. This means capital M, moles per 1,000 milliliters of solution, 2.31 moles sodium chloride per 1,000 milliliters. So now, using that, I can put in the numbers here. 2.31 moles of sodium chloride per 1,000 milliliters. Notice milliliters times moles sodium chloride divided by milliliters. The milliliters cancel out because anything divided by itself equals the number 1. So I can do this, and I'm going to get the right answer. Now, this is step 1. I'm going to just pick up my calculator at each step, clear it. 451 times 2.31 divided by 1,000. And I'll round this off. This is 3 significant figures. 3 significant figures, exact number. To 3 significant figures, I get 1.04 moles of sodium chloride. Am I done? No, I'm trying to get grams of sodium chloride. So now we need step number 2, moles of whatever we're trying to find to grams of whatever we're trying to find. And how do I do that? Well, the only number I have to start with moles, I just calculated. And what units do I want to get to? My answer, grams of sodium chloride. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of that ratio. Whatever I'm trying to get rid of goes underneath, and we're talking units, and I'll write those in. And where do I get these numbers? Well, let's look at important information, which I still haven't posted yet. I'll do by Monday. Quiz 4. And you will be given the following. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound equals the sum of all atomic weights. So I have to take a second to open up my periodic table. And now I know for every 1 mole of a compound sodium chloride, the number here, grams, is the molecular weight of sodium chloride. And that's the sum of all atomic weights, 1 sodium, 1 chlorine, and the 3 significant figures, sodium, 22.989, Na becomes 23.0. Chloride element, 35.45 becomes 35.5. Add these together, get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. This is 1, this is 1, this has 1. So this would be 58.5 grams. Before I continue, guess what I'm going to do? I'm going to do it over here, moles of sodium chloride times my grams of sodium chloride divided by moles of sodium chloride. And notice I have moles of sodium chloride on top and bottom. Anything divided by itself equals number 1. Someday I'll use another letter of the alphabet. Do you have a favorite you want me to do? Email me or send it on chat. And this cancels out and I'm left with the right units. So now I'll happily pick up my calculator, clear it, put in 1.04 times 58.5. And my calculator, the three significant figures, I'm going to round it off because we're almost out of time. And the number is 6.08 times 10 to the first grams of sodium chloride. So if I measure out 60.8 grams of sodium chloride and dilute it to total solution volume of 540, 451, then I will have this 2.31 molar solution. Now, if I look at the clock, which I just did, we're just about out of time. I will go through more of these problems next Monday. It's Wednesday. Don't forget, yesterday's lab, you better turn in. Don't forget, you need to take one picture of your periodic table cards that you're using for that lab and include it in your upload in the lab, in the PDF. You can insert it. And with that, I'll see you next Monday, unless you're coming to my office hours tonight. And with that, I'll say, gang gesund, goodbye. I stole that from Granny and the Beverly Hillbillies.